35 years of vast experience in cement industry in the field of projects, erection, commissioning, operation, and he is heading JSW plants across India. He also served as a deputy director Dangote Cement Industry, Nigeria, and he holds a mechanical engineering degree. So over to you, sir, for conducting this session.
Thank you. The great introduction by you. Thank you. Welcome. Morning, all participants, and also especially all the what was regarding the energy efficiency improvements to the retrofits and new technologies. So now we all are aware that the carbon footprints, reduction of CO2, and decreasing the power consumption, decreasing the fuel consumption in the cement industries. But today, globally, the coal prices are gone up like a hell. It is touching the sky now. So this is the only way we to reduce, then we will survive the cement industries, especially as on today. I request all the participants, especially Benraj, Madhu, Pankaj Gupta and Vikram, should take the time 20 minutes for your session and including question answer session. I think question answer will be separate, Vaibhav?
Yes, sir. We'll have Q&A session at the end of the session, sir.
For all the presentations.
For all the presentations.
Okay. Then you can present your complete data, whatever the requirements that is there in the 20 minutes. I think after 20 minutes there will be some bell is not available here in real this we'll have a bells and all these things. So please try to understand the time. Time is very precious. Please start, Mr. Bernard Ronald Henrich and Rahul Sharda, please. Thank you.
Thanks a lot, Mr. Babu. I will try to share my screen first of all. Is there which button to be pressed?
Share is there bottom.
Share. Okay, and then I am the presenter, but which screen is shared?
Your screen. Window.
Yeah, you can click on the window, sir.
You click on the window.
Click on the window.
Yes, sir.
And your file might be opened there already.
Okay, can you see something?
No.
Not yet, Mr.
No, not yet.
I will stop the presentation and restart the presentation.
There are 3 buttons.
File, edit, share, view on the top left side. Here's a share. Sorry, now I got it.
Yeah.
Yes, there we are. I was in the top menu. Good. Is something now visible?
Not yet.
No, not yet.
Not yet. Let me see this again and confirm sharing.
Yes, now it is coming.
Green light around it. Okay. So thanks again. On behalf of Gebrüder Pfeiffer, also my colleague Mr. Rahul Sharda is there, and I would like him to give some first words.
Okay. Good morning, Mr. Bira Babu, sir, Chairman of the session, my fellow participants, and all our listeners. We would like to thank CIA and CMA for holding this virtual conference time and again, showing a way during difficult or challenging times of COVID and beyond. We at Pfeiffer, with more than 155 years of older legacy, are continuously working as a reliable grinding solution supplier partners to cement, steel, mineral, various other industries globally, including India. Gentlemen, there was a panel discussion yesterday participated by industry stalwarts worldwide, and the session was concluded with highlighting the levers which we have to pull to achieve this huge task of net zero carbon future. I would like to again list that levers. That is, first lever is new innovations or improvement in technologies. Second lever is energy efficient systems, which is electrical energy or thermal energy efficient systems. And third lever is sports system digitalization. We can say that introduction of artificial intelligence, AI, or we can say it as a industry 4.0. And the fourth one is the availability of SEMs like slag, fly ash, whether it is dry or wet fly ash or other materials. Here we would like to mention that Pfeiffer as an organization since 1864, the year of our foundation, striving through innovation and continuous improvement in technologies to support various industries, mainly our cement industry. In 1894, Pfeiffer introduces its first mill to cement industry. In 1956, we provide first MPS series mill for raw material and coal grinding system to cement industry. In 1979, we introduces first VRM, vertical roller mill, for cement grinding to cement industry. Gentlemen, we set our own standards, we set our own goals in a way that we do innovations and to achieve larger industrial goals. In continuation to this, in 2006 or 7, Pfeiffer introduces first multi-drive MVR series mill to cement industry. And thanks to the industry, this mill is well appreciated and very well accepted in the industry. We can supply big mills for raw material and cement grindings with this series, MVR series design. And we have running installations worldwide. Name a few like Lafarge Holcim in Brozo, in Nigeria, and in Pakistan. We have installations. To give you more insight of our innovation and energy efficient technologies, at this stage, I would like to invite and welcome our colleague from Germany, Mr. Bernd Henrich. Mr. Henrich, from here you can take it forward. Welcome, Mr. Henrich.
Thanks a lot, Rahul. Thanks a lot to all the participants. And yes, that is exactly what Rahul says. We yesterday learned already what are the things we as a supplier of machinery for the cement industry can do to assist, to help to reduce the CO2 footprint at all. So one important issue is first meeting the needs of our customers. Sure. The cement industry is our customer and their requirements to fulfill the second main goal, the fulfilling of the interest of the future generation. That is the purpose you are looking for as a cement producer and the concrete industries. So we try to support you with the way of optimization to reduce CO2 footprint. It makes sense to look into this in detail. And as you know, the efficiency of a plant, the efficiency of finally the grinding systems is of importance because as known in the literature, as known from many publications, the power consumption which comes out of the production of cement, it is significantly driven by the grinding process. We learned already today and yesterday about net zero clinker production, which means waste heat recovery might be able to get electrical energy for the kiln itself. So to have a zero clinker production, but the energy required in the grinding of the cement raw material, as well as then the energy required in the grinding of the cement, that is electrical energy, which needs to be optimized to have an let's pave a little bit the way on this goal to become low CO2 emission or even net zero on the CO2 emission. And I would like to focus on this grinding processes to how to optimize it, and just to show you, like for an cement production itself. This is a general view of CEM1, which means OPC. OPC at 3600 plane, which is used all over the world. Sure, we will later come to the point of substitution of clinker and what is the effect out of this. But when I look for an OPC, a normal cement production, then average figure is 40 kilowatt hour per ton when doing this grinding in a ball mill system. The optimization by using combi grinding systems, roller presses in front of the ball mill gives a significant reduction in the electrical energy. Sure, the next step is the vertical roller mill, let's say state-of-the-art efficient grinding system, where we can come down from roughly, let's say, 40 kilowatt hour per ton to 27 kilowatt hour per ton of the clinker cement grinding, the OPC grinding. And what does it mean? This in view of the CO2 emission, and let's take an example of a 5,000 tons per day plant, which for India, let's say it would be a small plant. In the rest of the world, 5,000 tons per day plant, and the grinding unit for this plant is quite a normal size. So CO2 saving with a ball mill system, logical, there is no saving at all. By using combi grinding, roller press and ball mill systems, about 4,600 tons per annum of CO2 carbon dioxide could be saved. With the vertical roller mill, that is about 8,600 tons of CO2. And just to get an impression, what does it mean? 8,600 tons per annum. That is roughly 4,100 cars. And as we are Europeans, we consider a yearly driving range of about 15,000 kilometers. So just to see how it works out. When grinding efficiency can be improved, that gives a significant positive effect to the whole environmental situation, not only for the cement industry, but also if you look comparable to other optimization steps. So what kind of optimization Gebrüder Pfeiffer can do in this respect? For you, as a cement industry, we first of all are talking about the reduction of the clinker factor. Reduction of the clinker factor is a main step. We yesterday learned phase one situations by using supplemental cementous material, so fly ash, pond ash as a wet fly ash, which was stored somewhere, blast furnace slag. But let's say in other parts of the world, except India, also limestone, natural puzzolana, that are all materials which can use activated clay will come up as a supplemental cementous material. So this combi grinding in a vertical roller mill by getting optimum cement properties and doing this at low energy with a low amount of clinker. That is exactly what we as Gebrüder Pfeiffer can help you to get this done. And the second main important issue is the, let's say, fine grinding. So finally, you have to sell a concrete which has a good strength development, early strength development as well as late strength development. So by reducing the clinker factor, adding more additives, the strength development depends also from the fineness of the components. So achieving high strength in the final concrete with the product ground in the Pfeiffer vertical roller mill, that is the second step to go for optimization. What have we done in this view? The improving of pressure loss and optimization of the gas flow is a major step which goes into CO2 reduction, which means we have in the past 1.5, 2 years, we have optimized, we have newly developed a classifier or optimized further the classifier, the VR and the VC classifier types on the vertical roller mill. We have made optimization on the nozzle ring, on the gas flow in the lower part of the mill, in the gas flow in the classifier, and also the gas flow going to the system, then to the dust collecting system. That all has been done with CFD analysis, and not only CFD gas flow. No, two-phase simulation, powder to be considered in the gas flow. And this steps leads to optimization in plants, for example, in raw material, where the traditional vertical roller mill had about a delta P of 70 to 80 millibar, and we had suction pressure at the fan of a raw material grinding system of about 100 millibar at the fan. We could improve this significantly. We could reduce by 15 to 25% the power absorption of the fan. So this goes mainly in the gas flow related issues, and this power saving at the fan that gives you about 1.5 to 2 kilowatt hour per ton on the total plant power saving. And this total power saving means saving of cost and saving of CO2 emission finally. So it comes into your, let's say, less production cost and less electrical energy means also less CO2 emission. And by the way, just coming back to this picture, here you can see a MVR mill for raw material grinding, and you can see the easy and small arrangement. There is a simple steel construction in the for the feeding of the material. There's no building, so we are not only talking optimization in the operation cost, also the investment cost. With a vertical roller, MVR 5 vertical roller mill, you don't need a building, you don't need an overhead crane. So investment cost compared when you see a combi grinding system or a roller press building for finish grinding. With our vertical roller mills, you can save a lot of this costs, which are not directly machine costs, but which has to be considered in the total investment view. But let's have a look also to cement grinding, finish grinding of the cement. In the past, there was the standard is with a filter dedusting, and there is a suction pressure of about 63, 65 millibar at the mill fan. By optimization of the gas flow, by installing the new VC type classifier and so on, we are able to reduce this to roughly 53, 55 millibar, so up to 20 millibar saving at the mill fan. That gives you roughly 1 kilowatt hour per ton, 1 unit saving in the cement grinding, which means it is maybe compared to the overall power consumption, it is a small step, but 1 kilowatt hour per ton. Again, this is a saving effect. And that means the vertical roller mill grinding systems becomes even more efficient compared to the combi grinding or the finish grinding in other grinding systems. And it provides you saving of electrical energy, saving of costs, and finally, reducing the CO2 footprint of the complete plant. Another important point, as Rahul has already explained, use of latest technologies, meaning, for example, Industry 4.0, artificial intelligence. Yes, sure, Gebrüder Pfeiffer is on this way also. We have implemented several testings, and we have, let's say, a better version using artificial intelligence, which allows, let's say, an operator is using, and an operator knows his plant and his mill, but people are thinking in a certain direction and are driven by, let's say, the history, the experience. And if you have 4 or 5 variables, you might change one of them and look for a little bit influence. The beauty of using artificial intelligence rules is that once we get the freedom to vary the parameters, there could be operation conditions related to the fan flow, related to the speed of the grinding table when you have a variable speed drive, related to the feed rate and things, which nobody has thought about it. And we were able in some pilot installation, which means, for example, a cement producer in Germany, we were able to reduce the specific power consumption by the use of artificial intelligence by more than 15%. And in Sweden, in another plant, we were able to reduce with the artificial intelligence the power consumption, but also what is quite important, for example, optimization of the fuel consumption. So there in this plant, the beta version was used for the hot gas generator. And that are the next steps to go. It is not yet, let's say, on the market. We are not going with all this IT technologies, smart technologies onto the market just to sell it. It has to make sense, and it should be plant-wise installed and optimized, let's say, from our customer support centers. And looking for this hot gas generator, that brings me to the second important step, because we were talking about electrical energy, but thermal energy is also a very important point of view. And thermal energy is related to the production of fuels and the handling of material. So there's VII A also active, for example, special in the non-fossil fuels used in hot gas generator. We all know the coal-fired hot gas generator, but coal is still an expensive fuel. It has to be handled, it has to be fine ground or broken and so on. Wood pellets, rice husk, alternative fuel, garbage, which is available. Bio-oil, for example, we have installations where they use the bio-oil out of food industry. And that is this waste material from the food industry is free of charge fuel for the oil-fired hot gas generator. So looking into this direction is the next step to go. Also then reducing, let's say, water injection. Dynamic water spray system is a tool which allows, let's say, to overcome laziness of operators. In the plant, we all know that it's easy to spray some water on a vertical roller mill. If you require it or not, it's the easiest way to do it from the control room. But there are tools which helps us to overcome then the operator, because he never reduces the water spray later on, and everybody is complaining the material quality, the heat requirement, and so on. So that a dynamic water spray system, when it was installed, it gave a significant step ahead for the reducing of the water, because water spray not required means increased thermal energy, and that has to be avoided. So there are plenty of steps which allows us as Gebrüder Pfeiffer to improve your operation. We cannot reduce the CO2 emission out of the clinker production itself. But we can assist with our systems, with our mills, in the optimization of the electrical and the thermal energy requirement in the process of grinding. We also are active in the, let's say, activation of calcined clay. Calcined clay will come up. Its reactivity of calcined clay is reported to be even better than of blast furnace slag. So maybe at a certain time, calcined clay can substitute the blast furnace slag as an additive. And calcining, this means thermal treatment and grinding of the clay. So we have solutions for this. Also, we have solutions when we talk about pond ash. Pond ash is stored and is wet, and it has to be transported to the grinding units. So either you transport 20% of water on the truck, or you use, for example, Pfeiffer dryers for getting the pond ash, first of all, reduced in the moisture, and then having less transportation cost, because on phase 3 CO2 emission, the transportation cost and so on is also to be looked into. So that are plenty of points where Pfeiffer is prepared to help for optimization. We cannot make the cement zero CO2 emitting. But we are on the way to assist you and to provide you solutions to this. And here you can see, let's say, our team in India and myself. And I think you are aware of all of the people. So feel free to contact us and to further that we can look into your project and your optimization. Thanks a lot. That's the end of my presentation. So the sharing screen is redone. No, I'm still sharing and showing the program. So
Yes,
let's
yes,
see
you
how
can.
I stop sharing.
You're done.
Good.
Thank you, Henrich. Thank you, Rahul. Rahul, you have set a context very nicely.
Yeah.
And Henrich has given a in a precise manner, very important points clearly mentioned in the presentation. Thank you, Henrich. The question answer session will come in the end.
Okay,
Thank you.
sir.
And we welcome Mr. Vikram Gupta from KHD. He is a designing department looking after, he is doing so many, almost all the plants, he is taking care of the designing and equipment for along with the German team. So we welcome Mr. Vikram.
Thank you, Veera Babuji. Thank you, Session Chairman. I'll share the presentation first. Is the screen visible, sir?
Yeah.
Yes.
Visible.
Very good morning, Session Chairman Shri Veera Babuji. Thank you very much, sir, for giving me this opportunity, and also CII. Very good morning to my co-panelists and the participants. I'm K. Vikram, working in KHD Humboldt, India, presently as a Deputy Vice President in Parts and Services Division. I have 21 years of experience. As you can see, my today's presentation topic is maximizing kiln potential through KHD's modernization solutions. The purpose of this presentation is to share an out-and-out case study where how can we improve or maximize the kiln potential of a particular plant. I have taken a case study here. As you all know, cement capacity is increasing in an increasing trend, and every year we are witnessing 7 to 10% capacity increment. Most of the times, this capacity building is done through the new projects, whether it is brownfield project or greenfield projects. But in our opinion, there is enormous chance to increase the capacity by upgrading the existing setups also. And under this, the utilization of the existing kiln to maximum potential is one area which we can explore. Through this concept, not only increasing the production, but also the carbon footprint of the existing plants can be reduced drastically, because these plants were installed 20, 10, 15 years back. So the technologies are not relevant to the present cement production requirements. So there is huge potential to reduce the carbon footprint as well. To cater these demands, KHT with over 160 years of experience, time to time have modified the technologies and introduced latest technology, a lot of first of innovations into the cement industry. My colleague has already shared various latest technological developments in pyro process system and grinding system. So here I'll just give a brief and then I'll go into the case study. The type of modification in the preheater system includes the latest high efficiency preheater cyclones modification, whether it is KHD preheater or other competitors preheater. We are able to do the modifications in cyclones. There will be some tailor-made modifications, optimizing the dip tubes to improve the collection efficiency as well as to reduce the pressure drop, and the suitable riser duct modifications in the preheater, and high efficiency top cyclones to improve the overall dust collection efficiency of the preheater system, and new generation clinker coolers. And if it's a grade cooler, keeping the existing structure as it is, the complete moving rate can be replaced with the latest grade plates, and state-of-art low NOx alternative fuel calciner, and there are other solutions as well. In grinding, we have the V-separator, static separator replacements for improving the classification, and also the latest generation dynamic separators to improve the productivity and also to reduce the specific power consumption, and also modifications related to ball mill parts and roller press parts in the grinding section we are working on. Coming to the subject topic here, I'm going to talk about a turnaround study of Kalyanpur Cements, which is the Dalmia Group plant. DCBL, one of the top 5 cement producers in India, has taken over this plant in 2018, Kalyanpur Cements, and this plant was supplied by KHT in 80s. And after the takeover, DCBL has approached KHT to do the evaluation for increasing the capacity. So our plant audit team went to the site and done the detailed plant audit to identify the debottlenecking areas. And we immediately submitted a technical proposal to the customer. And after rounds of discussions, the project has been finalized. And the DCBL has placed the order on KHT in 2019. And this was a fast track project to execute the complete EP supplies in 7 months. You see the key data before the modification. The pyroprocess line was operating at 1625 TPD with 40 to 43 millibar pressure drop at preheater outlet, and the temperature for a 5-stage preheater with 370 to 375 degree temperature. And the raw grinding system, roller press finish mode circuit was there, but of old generation. 120 TPH it was giving at a 12% residue on 19 micron. This is the typical flow sheet. Just I wanted to show the material flow here. This is similar to the latest pyroprocess schematics, but the only thing is that airlift system was there to feed the kiln feed into the preheater, 5-stage preheater. Rest kiln, 3-tier kiln, and then grate cooler is there, kiln feed system, kiln feed bin, etc. And coming to the raw mill section, it is a different circuit from what we are seeing in finish mode in roller press today, because at that time in 80s there was no V separator. So the drying function was done in a pneumatic hammer mill and also size reduction. From this, the material lifted to the static separator. From the static separator, the rejects are going to the roller press circuit, and the recirculation material from the roller press circuit going to the dynamic separator, and product collection takes place here and then transported to blending silo. Rejects are back to the roller press circuit. So this is a completely different circuit what we are seeing today. Coming to the implementation of the proposed modifications, in kiln feed section, we have modified the areas, components where the capacity was lower. We have identified what is the capacity that we can guarantee from this kiln and what capacity we can achieve. Based on that, we have estimated the capacity balancing. Through that, certain equipment we have modified, like the extraction gates from the blending silo, the air slides, transportation air slides, and also the elevator feeding to the kiln feed bin. And also the flow meter system, kiln feed flow meter system. Here in the flow sheet, you can see all the red color equipment have been replaced. The extraction gates from the blending silo, air slide, because the capacity was not sufficient, so we have installed a higher capacity equipment. And preheater, the kiln feed bin is installed in the preheater building. And then new elevator is proposed because capacity was not sufficient for the earlier elevator. Client has replaced the airlift system with the bucket elevator for the preheater feeding, and then air slides of higher capacity are installed for feeding into the preheater system. In the preheater system, the major modifications includes replacement of the top stage cyclones, earlier generation top cyclones with the latest generation pin cyclones of KHT. There are two purposes of replacing this top cyclone. One is to suitable for the capacity enhancement requirement. The other one is to improve the overall collection efficiency of the preheater system, because we were not able to modify significantly the complete cyclones because of the building structural layout constraints. But to top cyclone, we have the opportunity, so we have replaced the better cycle. We have replaced with the two new cyclones in the top stage, and also a inline calciner. Earlier, the plant was operating with a separate line calciner, so we have provided a new inline calciner of bigger diameter outside the preheater building completely. The advantages of this tubular calciner design, as you are already aware, it is aptly suitable for the solid AF utilization, because the velocities are sufficient for lifting the solid particles. And second thing is that the kiln gases and tertiary air gases mixing is taking place in the tubular calciner with the help of pyrotop. This is a unique design in KHD calciners, where we have pyrotop on top of the calciner, which takes care of the complete turbulence and the mixing effect, because the residual oxygen that is coming and also the burning particles, meal and fuels to be mixed well before going into the bottom cyclone. Sometimes we have the residence time, but without turbulence, we will not get the required combustion. So with this pyroclone with pyrotop design, we have the complete mixing effect, and before reaching the top cyclone, we will get the complete combustion. And we have also installed a pyroclone calciner firing system. This is also a patented design of KHD. It's a simple design, but unique. because the meal and fuel both are introduced into the feed box before entering into the gas stream. So the pre-mixing already takes place, and then pre-mixed material is uniformly distributed into the gas stream that gives the uniform heat distribution across the calciner. So it avoids the temperature peaks, and sometimes in old calciner burners, we have seen that the refractory fails too soon because of the high temperature. Because of this uniform heat distribution, this problem will not be there. The other advantage with the pyrobox calciner is that there is no additional requirement of primary air, which contributes to the heat consumption reduction. Apart from this, in the pyro section, we have done some tailor-made modification, because on case to case, we have to identify these modifications. We have provided optimized dip tubes and partial gas rise and duct modifications we have done. And also bottom cyclones, raw meal pipes have been increased to suit the capacity. A new bigger preheater fan with motor and VFD is also installed. Here you can see the 3D general alignment drawing of the preheater. The top stage twin cyclones are replaced here. The gray color picture you can see here. And here also on the stage, all the stages we have replaced the dip tubes, and the partial gas riser duct modifications have been done. And on the right side of this middle picture, you can see an independent calciner, inline calciner taken outside the building. And this calciner is supported on 2 columns, and the other side we have taken the support of the existing preheater building. So the retention time has been increased up to almost 8 seconds. One is for the increased production, the other one is for the future potential of solid AFR utilization. And also we have done these modifications, as I explained, about the pyro box and also the kiln inlet section and kiln riser section. In the kiln section, we have increased the speed of the kiln from 3.6 to 6 RPM. And the critical components of the kiln for the higher capacity have been checked through the stress matrix analysis. And we found that some of the critical equipment like kiln shell has to be replaced because it's not suitable. So we have done thorough analysis and given the recommendations and modified kiln shell of approximately 30 meters. And coming into the cooler, we have used the outside skeleton and replaced the complete moving grid section of the cooler with the Pyrostep square design latest generation cooler plates. And also to take care of the increased gas volume requirement, Bagos capacity has been enhanced and one new Bagos fan is also installed. Just a schematic flow sheet. You can see the red color pictures here. The kiln gearbox and motor replaced, partial modification of the kiln hood we have done. And also in this particular case, existing burner from the group plants has been used with the tip modification, but the swirler blowers were not suitable, so we have replaced the swirler blowers of suitable capacity. In the cooler, as I already explained, the complete moving rate has been replaced, and also with the set of new fans, and water spray system is introduced. In the fine coal dosing system, the complete existing coal bin has been utilized, and the extraction system has been modified with the Coriolis feeders for both kiln as well as calciner firing. Here you can see in the picture, complete 2 extraction systems are taken independent, one to the kiln burner, the other one to the calciner burner, and both are dedicated, having a transport blower and one common standby blower. These are the summary of modifications which I have already explained. You can see here the top cyclone replaced with bigger 4.8 meter dia, and the inline calciner has been installed, suitable for almost 8 seconds retention time. Preheater fan is new, and also in kiln we have increased the speed to 6 RPM. Motor has been replaced. In kiln burner only tip modification has been done. In clinker cooler complete moving rate has been modified. In kiln Bagos, the capacity has been enhanced and the kiln Bagos fan is installed. In fine coal dosing system, new Coriolis of 10 TPH each for kiln burner as well as calciner burner is installed. In raw grinding section, because one side we are increasing the capacity of the pyro system, the other side raw grinding capacity should be suitable for catering that requirement. So we have seen what are the potentials in the existing roller press system. Being an old design, the speeds were very low, 1.4 meter per second. So we have seen that there is a potential to increase the speed from 1.4 to 1.6 meter per second by changing minor things in the gearbox. So existing gearbox can be retained. So that we have done. And also the motors were not suitable. Then we have replaced the motors with the bigger capacity, 900 kilowatt. RP hydraulics and the roll cock system software, the latest generation have been upgraded in the existing system. As I already shown in the flow sheet, the existing system has this pneumatic hammer mill for the drying. As now we have V separator for the drying purpose as well as for the primary classification purpose. We have installed a V separator, and for the higher capacity, one new dynamic separator is also installed. And these are incorporated in the finish mode circuit with the existing roller press. Two recirculation elevators are installed for V-separator and roller press discharge material handling. And also 2 product collection cyclones and 1 SK circulating fan are installed. You can see in this general alignment drawing, the fresh feed is coming to the V-separator here, and the hot air duct is shown here, hot air duct. And whatever the drying, after the drying, the fine particles will be lifted to the dynamic separator. The dynamic separators are going back to the roller press circuit. And here V-separator discharge material also through elevator and one belt conveyor is going back to the roller press system. And from the roller press throughput is going to a elevator, and from the elevator through a belt conveyor again close circuited with the V-separator. And the fines are collected in the cyclones through a circulating fan and then goes to the blending silo through set of A slides and elevator. So these are the modifications that we have done. Again, the summary of the modifications already explained. 1.6 meter per second we have increased. Motors are replaced with bigger capacity 900 kilowatt. New V separator of this size is installed and one new dynamic separator has been installed. And the new product collection cyclones of 4.5 meter dia, 2 numbers, and one big separator fan is installed. This is what we have done. And coming to the performance. Pyro process system, if you see, we have given certain guarantees during the contract signing time. All those guarantees are achieved. But when I compare this data with the before modification, these results are mind-boggling, seriously, because 1625 TPD has been increased to 2617, 2617. The specific power consumption for certain equipment, which I have given at the table below, 17.63 kilowatt hour per ton is reduced to 14.83. And specific heat consumption, earlier it was operating 841 kilocal, which is reduced to 738 kilocal. And NOx also with 1359 is reduced to 792. The point is that without any SNCR system, with this modification, they are able to meet the NOx guarantees. What is the takeaway from this modification? One is 61% production increase with improved quality. That is one biggest plus for the customer. Second thing is that specific heat consumption reduction of more than 100 kilocal per kg clinker. That is the biggest takeaway. And approximately 2.8 kilowatt hour per ton of clinker power saving. And then significant NOx reduction, approximately 550 milligram per nm cube at 10% O2. So these 4 biggest takeaways for the customer, even if ROI is estimated, whatever the estimated ROI that has achieved early. The point is that for every plant, we will not be able to meet this type of guarantees, but in this particular plant, we have the potential and we are able to tap that potential. Coming to the raw mill system, the contract guarantees are met easily. And if you compare the figures with the before modification against 120 TPH, we have achieved 201.5 TPH. And in the power consumption also in finished mode 13.6, it was operating earlier. Now the plant is operating at 12.26 kilowatt hour per ton. So again, the takeaways in this raw grinding modification, production increased by approximately 68% and 1.34 kilowatt hour per ton of raw mill saving in specific power consumption. These are the gains client has already expected that when they're doing the project with KHT, and we have given certain guarantees. But the biggest takeaway for the environment is this is the certificate that we have received recently when we completed the PG test in March. But the biggest takeaways for the environment is the CO2 reductions. If I calculate the specific power consumption reduction and the specific heat consumption reduction and the coal, whatever the coal that comes down, the overall CO2 reduction per annum accounts to almost 28,000 tons. So this is the point which at the beginning of the presentation I was stating that there is a good potential in the existing plants to improve the operational efficiency in terms of productivity enhancement, in terms of specific power consumption reduction, specific heat consumption reduction. Apart from that, we also can contribute to the environment by bringing down the CO2 emissions. So we proudly say that the mission got accomplished. This is the last slide. I'll conclude saying that we are also offering other services, like we conduct the plant audits, whether it is a process audit, mechanical audit, or a quality audit. And we are providing upgradation solutions for all types like grinding, raw grinding, clinker grinding, and pyro process system. We are into the the special projects, clay calcination technology also. We have the design, and we are also offering clay calcination technologies to various customers. Especially the whole India is now moving towards the increasing the TSR percentage. So here we have variety of technologies for improving the TSR percentage up to 80-85% in the calciner through our pyro rotor latest technology. And we have also supplied kiln bypass systems. One is already under operating, the other one is execution with the biggest group in India. And we also provided training and technical workshops. You are already aware, I think KHT has already supplied various NOx abatement solutions and also SOx abatement solutions. Vision of our services division is to provide, whenever we do this type of upgradation solutions, to improve the productivity, that is productivity enhancement. Second thing is to achieve the energy efficiency, and finally provide the solutions which are environment friendly. With this, I conclude my presentation. And again, once again, I thank Chairman for giving me this opportunity, and CII. In case of any doubts, you can contact us at this mail ID or the mobile number. And at the end of the session, I am open for the question and answers. Thank you very much, sir.
Thank you, Vikram. Done a very good presentation, because reduction of CO2 is the major role required for the cement industry across world now. We are all also agreed to the nation in the Italy conference also for environment reduction of CO2. Thank you once again, Vikram.
Thank you, sir.
Now we welcome Mr. Madhusudan. He is an expert of ICANN. All cement industry is well known him. So, Madhusudan, you can start your presentation.
Yeah, good afternoon, Mr. VII Babu, Chairperson, and the delegates on the virtual dais, and all participants. So, my screen is available.
Right, Madhu.
Yes, sir.
Now it is okay.
Okay?
Yes, sir.
It is okay.
Yeah. So let me thank CII for giving us this opportunity to showcase the couple of references of pyro projects, mainly retrofitted to increase the RDF utilization and to meet the new 2019 Euro norms to control the NOx, SOx, and ammonia and particulate emissions. All along, I have been branded as a cooler man, and now I'm jumping into preheat and projects, pyro projects. So before I show some of the exciting slides, let me share with you when ICANN started and how it started. And you all know that in 1983, the foundation was laid by Mr. Carl van Wedel. And in 1984, we received first fixed inlet called ICANN kits, clinker inlet distribution system, which has revolutionized the world in clinker cooling technology. And then in 1989, we have supplied first pendulum cooler without any bearings, rollers, or lubrication inside the cooler. And then in 2002, ICANN has taken over a company called PSP. It's 150 years old, cement machinery supplier based in Czech Republic. And later on, integrated the PSP preheat and kiln to ICANN cooler. And in 2011, we have supplied 3 big capacity coolers of 30,000 tons per day in China. And those coolers have been integrated with the reputed kiln suppliers. And subsequently in 2014, we have supplied a 5-stage preheater, kiln and cooler, total pyro project in Turkey. And this has created a very remarkable results. Like I was told that 690 kilocalories have been achieved and 11.5 kilowatt per ton for the kiln drive, preheater fan and cooler section, and kiln nose cooling ring fans. So which is a remarkable milestone achieved in this project. And subsequently in 2018 to 22, we have done 4 major pyro projects executed in Europe. So the ICANN started with the kits, and then the cooler, and then the pyro line, and now the turnkey solutions for the cement industry. So this is the small graph showing the total clinker produced and cooled by ICANN cooler. If you see in the black color, it shows the clinker cooled by kits, and red shows the clinker cooled by the pendulum cooler, and the yellow one is the pyro projects by ICANN. And all the 6 continents, our presence is there with the 728 projects throughout the globe. And as of today, ICANN is cooling 1.09 billion tons of clinker per annum. So, and we have started humble beginning with a fixed inlet, for the coolers, and then the Pendulum coolers are almost about 360 installed now. And then I would like to come to modernization in the VAC plant. And this is the 2400 TPD do not drive cement clinker line in VAC, that is Hungary, has been successfully recommissioned and put into production in April 2018. In less than 2 years, ICANN completed an enormous task to deliver the project on EPC basis. The main target of the project was to adopt the pyro line for producing clinker using up to 100% RDF in calciner, and the 2 lower cyclone stages were replaced. A complete new tower with the inline calciner was erected. The new bypass system as well as the new static inlet in the clinker cooler were installed. The upgraded kiln line combines the latest industry practices with the most modern and updated process technology. So you can see here this bottom 2 cyclones were being retrofitted with the bigger ones and with the gas ducts. And then in the second stage, the existing calciner was extended. And this is some of the photos where you see the execution on the ongoing. And this is how the final preheater tower was retrofitted with ICANN technology. And this is a short film showing the activities in this plant. Yeah. So what we do is, as a precondition, we do the CFD modeling for all our preheater projects, because basically the preheater is nothing but it's the airflow techniques. You need to know how the air is introduced and how it is being directed into different systems. And another modernization plant we did was Berglenfeld plant in Germany. This is a Heidelberg plant, and ICANN was awarded a contract for engineering, supply, and installation to upgrade the pyro line to 4,000 tons per day. They had 2 lines. One line is with the 2,000 tons per day, another line with the 2,000 TPD. So one line was completely scrapped, and one line was used to upgrade to 4,000 tons per day. So from raw meal feeding to clinker discharge, the contract included integration engineering, supply, and installation of add-on components of the raw meal grinding plant, etc. The upgraded kiln features state-of-the-art technology in order to reach the targeted production level and to comply with future emission limits. So the new production line comprises of 2-string 5-stage preheater with the inline calciner and Firebird Combustion for coarse RDF. ICANN's most modern preheater and calciner design ensures minimum pressure drop at maximum performance and high efficiency. So the kiln line was put into operation with various alternative fuels. This is the overview of the Berglen field. And this is one of the existing constraints were so heavy that it becomes really challenging to make the new equipment to fit in. And this is the overall view of the preheater tower with FBC. FBC is called Firebird Combustion, which is the ICANN patented product to fire very alternative fuels. So this is the overall scenario of the Berkeley plant. And this is the completely preheat tower is covered with the cladding. And a new line at Marker Cement Plant. This is the third project which IKN did the pyro modification in this plant. This is also plant at the beginning of 2020. IKN was awarded a contract from Marker Group comprising the engineering, supply and installation of the 3000 TPD pyro line from raw mill feeding to clinker transport. By upgrading this cement plant at Harburg, Germany, Marker leads the company towards sustainable future. The plant will feature state-of-the-art technology in order to increase production reliability and to reduce the emission norms. So this is the single-stage preheater with inline calciner, and FBC was introduced, and it's a 3-pair kiln, and IKN Pendulum Cooler with roll crusher and bypass system, and raw mill feeding and burner filter and clinker transport were also included in our scope. So this is the overall view of the plant, and it has got a raw mill feeding, then the preheater, 5-stage preheater. Cyclones are 7.7 meters, and steel construction preheater tower with 110 meters height, and FBC, and 2 elevators, and dust transport system, and ID fan, etc. This is the overall view of the logistics of the cement plant at Marker. And the preheat erection was going on. And this is a huge task for IKN to lift the kilns in a fully assembled condition. And the cranes of almost about 190 tons and second crane of 120 tons have been deployed to install this kiln in a very short time. And the kiln is ready to receive the clinker. And we did this with the total team in Germany, the contractors, and almost about from various countries people, and it was a successful project for IKN. So now coming back to the alternative fuels. So this is the very interesting development in IKN. It's called Firebird Combustion. And so this Firebird Combustion can be used in conjunction with the pre-calciner. And it is a static equipment. There is no rotating elements inside. And this is a completely refractory line equipment, and hot air from the tertiary air duct will be introduced here, and alternative feeding will come from the top. And these are all the heat sinks, and those heat sinks can be adjustable. And the material which is coming inside the FBC will fly away smaller particles into the calciner and then takes the complete burning. And the heavier particles will settle on this heat sink and they'll get burned so that they'll get better residence time there. And this is the equipment in action. And pre-installation on site. And this is the inside view. And if you see here, this acts as heat sink. So this is the particles on the blades, heat sink. And then the temperature can go up to 730 degrees centigrade inside, so that it retains the heat, and then immediately the heavy particles, if it falls on the heat sink, they get reduced in sizes. So this is a small fill. So this is the FBC location, and the tertiary air duct is taken as a small branch and introduced into this one, and this is connected to the calciner part of it. So this completes on preheater side. Now I'm getting into pendulum cooler. Already I think my colleague yesterday explained, and I don't take much time on the cooler. So I quickly run through the system. And the monoblock pendulum cooler, you all know that IKN pendulum cooler is the best in the industry today. And you can see this is the old IKN Conda blades. And then the new IKN Conda blades are redesigned so that it'll have a direct flow and a uniform distribution of air and the less pressure drop. And this is how it looks like, the new Conda wing blade. And this is Conda wing blades assembled in the Pendulum grade boxes. And if you see our first generation IKN cooler is having the pendulum suspended on the sides of the casings, and this is no longer used, and we keep updating our technology generation after generation. And today we are nth generation, and this is the pendulum, how it looks like. Today's very compact equipment, and we call it as a linear pendulum suspension because so the motion at the pendulum is converted into linear motion on the top, so that there is no arc motion, so gaps are controlled very much. And if you see here, the clinker simulation we have shown, on the fixed inlet clinker comes in here, and then when it comes to the movable section, the clinker bed is slowly received and then transported forward without any disturbance to the bed. That is more important factor in the clinker cooler. We should not disturb the bed. The bed can be disturbed either by air or by the conveying elements. But in our case, the bed is not disturbed. And for every 2 stationary doors, we have 1 mobile drop. And then as the sinking phenomena of the mobile frame is arrested, the gap between the mobile and stationary will remain for a longer period of time in case of IKN cooler. And that is one of the major benefit our customers are getting, that efficiency will not deteriorate over the period of time. And roll crusher, you all know, it is either kept at the intermediate position or at the end position, depending upon the capacity of the plant and then the requirement of the customer. And then we have a TDE, it's called a dust removal system. And normally what happens is the 4th generation cooler or walking floor coolers claim that there is no spillage, but we have found that the spillage is being removed from the underhead compartment in a very hot way. And whereas in our case, this is removed by means of TDE, it's called tube dust extractor, and which looks like a very simple conveyor of about 4.5 inches diameter. And inside the tube, there are discs are there connected by the chain. And then this conveyor need not run at 24 hours a day. And it normally in a cooler, it works between either 40 to 80 minutes in a shift. So whatever dust is accumulated inside the underhead compartment will be taken out by this tube conveyor in IKN coolers. And another innovation IKN did is Dld drives. You know, we are the first people to come back to from mechanical to hydraulic, and we are the first people to come from hydraulics to mechanical now. And now since technology has developed, and we are able to simulate the similar kind of motion, that is slow forward and quick backward motion by using a VII A technology and gearboxes. So this is a single drive cooler, and similarly we have a twin drive where the capacity goes beyond 5,000 tons. We operate with the 2 linear dynamic drive. So this has got advantages because you don't need to have a hydraulic room and then clumsy of hydraulic pipes, and there is no need of heavy maintenance in terms of hydraulic drive system. So the maintenance is very less in case of DLD. So these are the references of DLD drives since 2014 to till today. And almost 86% of current coolers we have been supplying with the DLD drives. And the another challenge we faced is the cooler recirculation system. So what happens when the industry started demanding a high WHR power from the cooler? So we had a challenge. The high efficient cooler will automatically have a less heat in the vent. So with the less heat, we will not be able to generate a power which the conventional cooler or low efficient coolers will generate. So what IKN did was, we have taken a mid-air or hot air from the vent and then recirculated back into the cooler underhead chambers. And by doing that, we could enhance the WHR power considerably. So what we did was, we are able to give at higher efficiency, recuperation efficiency to the cooler, and at the same time give the maximum possible WHR without compromising the recuperation efficiency. Because the firing the less coal is more advantage rather than buying the coal and then producing 20% less efficiency in WHR systems. So these are all the wide references we have throughout the world on WHR recirculation systems. And thank you, gentlemen. So I did the complete analysis of IKN cooler with the preheat and kill. And IKN is not only a cooler supplier, but we can supply the preheat or kiln cooler to meet the present norms to have a reduced NOx, SOx, and particulate emission with our new technology with the FBC and all that. And I would like to receive any questions if you have. And thank you, gentlemen.
Very good, Madhu. Very good presentation.
Thank you.
It is required for industry, reduction of fuel, reduction and power. That is the most important thing. So thank you once again, Madhu. You are doing good job in India. The question answer will come at the end of the session. So now I request. Thank you, sir. Thank you. I request Mr. from the Hassel Refractories Business Head, Mr. Pankaj Gupta, to share the presentation and explain how best helpful for cement industries to reduce the power consumption, fuel consumption, and also the coating, anti-coating refractory, whatever best. Welcome, Mr. Pankaj Gupta.
Thank you, sir. My PPT is visible, sir?
Visible, Pankaj.
Yeah, thank you, sir. Good morning, respected chairman, sir, and respected panel members and industry experts, and all the participants. I would like to thank CII and CMA team for organizing such a knowledge sharing event and providing me opportunity to put my views in this forum. As we all know, since the beginning of cement production, fossil fuels are used as main source of heat. But since last 2-3 decades, to reduce the dependency on the fossil fuel and especially to minimize the fuel cost, cement industry started to look into alternate source of heat. And now when entire world is talking about sustainability and net zero, so industry want to reduce its carbon footprint. So importance of alternative fuel increased tremendously. So what these alternative fuel, how they can help in reducing carbon footprint, and also how they affect the process of cement and refractory performance. So I will try to give my views on same. I'm Pankaj Gupta, working as a business head in Hasley Refractories and looking after Hasley business in India, Middle East, and East Africa. So topic of my presentation is minimize refractory challenges when using alternative fuel. So in my presentation, I will cover just Hasley brief introduction, Hasley products and characteristics, alternative fuels and refractory challenges, then Hasley product selection and some selected cases. So brief introduction, I will say Hasley is privately owned company established way back 1843. We develop, produce and sell refractory material. Head office, research and development and production is Denmark. Subsidiaries in India, Thailand, and with European sales office in Copenhagen. Worldwide, we are selling more than 50 countries. Main products are aluminum silicate castable and precast for cement, steel, and power industry, and also some other high temperature process industry. Annual capacity of the Denmark factory is 20,000 tons low cement castable annually, and also 1,000 tons of precast annually. From our headquarters, we provide engineering, consulting, and designing of refractory lining. All the related required testings are done in our own laboratory, where we carry out various tests to measure and secure material performance as per specific customer process requirements. We provide technical supervision for installation of all products. Supervision is carried out by highly skilled supervisor from Hasley or from our trained partners. So coming to the products, there are a variety of products. Mainly we are producing dense castables and precast. And in castables, we are covering traditional castable, gunning castable, low cement castable, and no cement castable. So to produce these products, we Hasley prefer to go with the high yield grade raw materials, like we are using Cymode for alkali resistance, andalusite for thermal shock resistance, mullite for strength providing, bauxite for abrasion resistance, corundum for high refractiveness, microsilica for densification and workability, various silica and alumina fines for mullite formation. Then finally silicon carbide for high thermal conductivity, which is only used for boilers and thermal shock resistance. So Hasley refractory products are basically known around the world for their outstanding properties and resistance to high temperature, chemical attack, thermal shock resistance, erosive and abrasive wear, buildups and slags, and mechanical stresses, which are the main challenges in a cement production process for the refractory. So coming to the alternative fuels, why this came into the picture? So as we all know, there is limited amount of conventional fuel available in the globe. So there is scarcity of the conventional fuel. So there must be some alternate for that. That's why this word came, alternative fuel. And also the high cost of conventional fuel, like Veera Babu sir already told that cost of all like coal, petroleum has been increased a lot. We have seen 2 to 3 times increase jump in the prices of coal. And at the same time, these alternative fuels provides a high calorific value compared to the fossil fuel or conventional fuel. This also add one more thing is that they are emitting lesser amount of CO2 and also greenhouse gases. On the other hand, they also, as we are not digging up the coal and other natural resources, so we are preserving the natural resources and maintaining the ecosystem. And later, lastly, when we are consuming all the waste material from the society, so we are making our society more clean and neat. Here is a graph where we can it is a graph to show lower heat value for the different fuel. Like here is for a specific grade of coal, here LHV is 27, where pet coke and tires are, we can get LHV value of 33 and 32. So it is better than coal. And also here you can see for agri waste, meal, bone, and sewage sludge, which is the completely waste for any society. And it can be used in a cement plant and to get the tremendous heat from these waste of the society. So there are different types of alternative fuels like petcoke, biomass, agricultural waste, fissile solid waste, pharmaceutical waste, rejected tires, non-hazardous industrial wastes are available, plastic waste, and then waste oils from the industry. So there are many type of industrial alternative fuels are available. So how these alternative fuels affect the process and also challenge the refractory performance. So as we know, there are availability of different type of alternative fuels, and these alternative fuels are having different type of nature of burning. So they provide different type of heat, means different grade of heat during its burning. So there is in the process there is poor when plant is using alternative fuel, there is poor distribution of heat, unstable precursor operation, and dusty kilns. And during the combustion of these alternative fuels, they form a lot of acids, and also they produce high amount of volatile gases like alkalis, sulfate, and chlorides. We have seen it is fact that from the municipal solid waste when plant is using, it introduces more ash and high content of alkalis and chloride in the system. And if you are using pet coke, so it introduces more and more sulfur in the system. And if you are using pharmaceutical waste, it introduces more and more chloride in the system. So different type of alternative fuel introduces different type of chemicals or acids in the system. So how these volatile gases and acids affect the refractory performance? Basically, these castable refractory are based on the alumina, and alkalis react with the alumina present in the refractory and form new crystal structure with high volume, and there is expansion of the these phases, and because of that this basically cracks. That is also called as alkali spalling. Here you can see it is made of this cup is made of castable, and it is heated with alkalis, and there is alkali spalling can be seen, and it is fractured into four parts. So same way sulfates react with the different alkalis, and when they react with the refractories, they causes the brittleness of the refractory, and refractory became very weak and fails early. Then chlorides, this has a tendency to infiltrate very easily in the refractory lining and condensate in the refractory. And when it reacts again, alkalis come, they reacts with it and forms a very forms vapor, and which makes the refractory not perform actually. So this also along with these chemical attacks, they also forms a lot of acids which causes build-up and coating in the especially in the preheater area, and more specifically in the riser area, feed pipes, and smoke chamber area. So here are the few pictures. This is the feed pipe from this picture is from site, and here you can see this feed pipe is around 60-70% filled with the coating, and there is restriction in the flow of the raw material. And here is the picture from the riser where these acids are stick with the refractory, and once this coating will be removed. Yes, sir.
Sorry to interrupt you, but we are not able to see your slides.
Sorry.
Sorry to interrupt you, but we are not able to see your slide.
Sir, slides are visible, sir. We can see. Can you
Slides
kindly
are
click
visible
from
for
your
us.
end, sir? Yes, sir.
Slides are visible.
Mr. Pankaj, please go ahead.
Yes,
Okay,
slides
sir.
are visible.
So this is the picture from one of the riser where refractory of a riser area is attacked by high alkalis and chlorides. Refractory failed within 6-7 months, and the red spot appeared. This is the picture of burner pipe where 100% petcoke is used, and refractory is attacked by high content of sulfur, and this castable failed within 3-4 months of period. So same way, if your refractory is not capable enough to take care of this alkalis, sulfates, and chlorides, it will fail prematurely. So you can see the picture of this bull nose, and also here picture from tip casting. So this is the need of our that when you are going to use the alternative fuels, you have to take care of your you have to upgrade the refractory, otherwise it will disturb the flow of material due to the more coating formation. Frequent cleaning of coating will be required. For that you need more number of manpowers to clean it, or more number of air blasters will be required. For that you need more electricity to operate that. Shorter life of refractory will be observed. Intermediate breakdowns to repair that failed refractories. There will be loss of heat, energy, and other resources like manpower, material to repair these damaged refractory. So to operate the plant for a whole year, more and more refractory will be required for over a period of time. So upgradation of refractory is need of the hour to cope the above issues and use more and more alternative fuels. So actually Hasley produces the refractory for different critical and non-critical areas of most of the critical areas of the cement plant, whether it's a burner pipe or tip casting or bull nose or cyclones or smoke chamber area or cooler parts. So we have a very unique product refractory solution that is universally known as modular lining. It has advantage. It has main advantages are it is mixed, vibrated, cured, heated under controlled conditions in our factory. It can be installed faster than the low cement castable. It don't require any drawing is required because it is already preheated. Thinner lining is possible. Longer lifetime is also can be achieved around 2.5 to 3.5. Sometimes it is 4 times. We have observed it is resistant to chemical attacks from alkali, sulfate, and chloride. So very less or no buildup has been observed on the refractory surface. I just want to show one small picture regarding the installation and this precast. So this is the precast. Size is around 250 by 250, and its weight is around 15 to 16 kg. So it's very easy to handle during the installation. So here's typical installation in the smoke chamber area. So first, this steel plates will be welded with the mother cell, and this base elements will be fixed by using proper expansion provision, and then these blocks will be folded by using L anchors fixed with welded with the mother cell. Same way it will go. So then this channels will be welded on the mother cell, and by using this washer and bolt arrangement, it will be fixed with the main elements. So this goes on, and the gap between the wall and precast elements will be filled with insulating castable and insulating blocks. So there will be 2-layer insulation behind the main precast. So this goes on. This completed precast smoke chamber. So this one more thing I would like to highlight. We have seen with castables, they have a certain lifetime, like it has shelf life of 6 months or 9 months, but these precast are having no shelf life, is the specific shelf life. It can be kept at site for 5 years, 10 years. They have no shelf life actually. So some selected differences for precast. So this is the plant with a 8,000 TBD capacity using a 10% alternative fuels. Actually, they are facing heavy coating issue in their riser area. We installed our precast lining here in the riser area, and you can see this is the picture after 4 years of performance. You can see the in the adjacent area where different castable is installed, and you can see the coating pattern. And while after 4 years, even after 4 years, you can see there is no traces of coating found on the precast surface. This is a plant from India. Line capacity is 5,500. They are using 50% petcoke in main burner, and you also using some amount of agri waste. When they started to use petcoke and agri waste, they are facing lot of coating issue in their smoke chamber area. So in 2017, we suggested for modular lining, and they installed it in their smoke chamber and riser area, and it performed for 4 years. After 4 years, in 2021, they have replaced again with the modular lining. This picture after 3 years. This is a plant from Canada which is using 100% natural gas, but actually because of this natural gases, they are facing lot of chemical attack and coating issue in their riser, and getting life of maximum 12 months in their riser area. So we replaced it in 2018. Whole riser was replaced with the precast lining, and now it has already crossed 3 years. This is a picture after 3 years, and still it is very contact, and we are still expecting 2 more years life with this lining. This is a plant using 30% AFR, and it is installed. Precast is installed in their cooler bull nose, and actually earlier they used to change the whole castable in this cooler bull nose, and now after using precast, they achieve life of 3 years. And we installed this time in 2021. We installed our precast lining 3rd time in this plant. So this is the plant from Germany, which is using 60 to 70% RDF, and they are facing a lot of patching work. They are doing patchwork every year in their cooler area. So in 2018, they replaced it with Hasley modular lining, and you can see the picture after 2.5 years. It is still in a very good condition. It looks like new one only. This is a plant using 80 to 85% RDF in Sweden, and they are facing problem in their cooler front wall, like just below the kiln, and After 18 months, you can see the picture of the modular lining. So this is a plant of using 15 to 20% RDF, and they are getting life of 12 months only in their takeoff duct area. After installation of modular lining, they were able to achieve 4 years life. This is picture after 1 year. This picture is after 2 years and after 3 years, and completely they have got the life of around 4 years in this plant. Hasley also produces inlet arch precast because in many plants they are able to get only 1 year life because of its tedious shape. So we also have a precast solution for inlet arch where 5 years life can be achieved easily. And depending on the plant problem, like we have seen many plants are facing a high coating issue in their mill pipes. So Hasley developed this precast for feed pipe also, where it can be installed very easily, and installation time is also very fast. 10 meters of feed pipe precast can be done in a single day. And you can see the condition after 4 years. It is just taken few days back from the site, and it is condition after 4 years. There is no traces of coating found in the feed pipe. This plant is using 100% pet coke, and in other feed pipes where castable is installed, we can find lots of coating deposited on the feed pipe castable. And also life wise, it provides 8 to 10 years life. We have seen already witnessed that. So coming to the castable part, this plant is using 25% of alternative fuel, and they used D59A castable, and you can see condition after 3 years actually. So after that, they replaced the whole. Many plants are also using facing problem in their lowest cyclone conical portion. So this plant using 20% of alternative fuel, and they facing a lot of coating issue in this conical part of the cyclone. And we installed their D59 castable, and they were able to achieve 42 months with less and less coating problem in this area. This is the plant from India, and they are facing problem cooler bullnose, and they were getting life of only 6-7 months. And we suggested for D52A castable in this area, and they have already achieved 2 years life. This is picture from 2018 during the installation, and this is picture from September 2020. We inspected the site and took this picture after 2 years. And this is the plant which is using 25% alternative fuels, and they were not able to get the life of more than 6 months in their burner pipe. We supplied our products and able to achieve 12 months life in their burner pipe. This is the plant which is using 50% pet coke in their burner pipe, and now they were able to achieve 12 months plus life in their burner pipe. Actually, they achieved life of 14 months in this plant. This is plant in India. This is the same plant where we also installed D52A castable in their tip casting area, and they achieved 18 months life in this tip casting area. Earlier, they used to get only 8 to 10 months life. So, by using good quality of refractory and better quality of refractory, cement plants can make their process smooth and stable. And by having a smooth process and stable production means to be more energy efficient. And longer lifetime of refractory means less and less use of consumption of refractory and less installation man hours. So used over the overall period of time, which reduces the CO2 footprint and maintenance, and also reduces the maintenance cost. So high grade, if plant as industry is using high grade refractories, so it will support cement plant to use more and more alternative fuel in their cement process. So that's all from my side. Myself, I have my colleagues Pricha and Daniel, who is looking after different markets. So depending on your market, you can contact these people. Thank you from my side. Over to you, Veera sir.
Thank you, Pankaj. You have given a very good presentation. It is enlightening to all cement industry people who are in the participation, and also of the participation we will convey the message to industries also. It is given a good information for the, especially for the, because AFR is only the solution for the industry in India as on today's coal prices going up.
Yeah.
So thank you once again for giving the presentation. Now we welcome Mr. Anirudh Dani from the JK Cement Limited, as he is a unit head for Dld Cement.
Yeah.
Mr. Anirudh?
Yeah.
Yes.
Mr. Rajiv Agarwal from my team is presenting.
Mr. Pankaj, you should
Yeah.
share your this presentation. Pankaj?
Yeah, I cannot control it. It is disabled now. Maybe CIA team can handle it. I cannot.
Mr. Raju, you can share your presentation. We have given you presenter, right?
Pankaj, you did. Okay, then thank you. Raju, you can start.
Yes, sir, we are sharing. Just a minute.
You are on mute, Mr. Raju. Mr. Raju, you open your presentation and then you click on share option.
You open first.
Yes, sir. Content is showing, sir.
No.
No, you are showing only desktop.
Okay. Just a minute. Please check what.
Rajiv, open your presentation, then click on share.
So I think there is some issue. I again reopen the same.
Sir, you can just yeah.
Yeah, now it is correct. Raju, now you open your file. Yes, correct, Raju.
Yes, sir. So now is it showing?
Yeah, make it a full screen, sir.
Okay.
Fantastic.
Okay. Thank you, sir. Good afternoon, sirs. So myself, Rajiv Agarwal, and I had here JK Cement was early, and along with me, Mr. Anirudh Dani, unit head, and Mr. Ashish Kulve, production head here. First of all, we would like to thank the CIA and CMA for inviting us on this platform. Sir, our plant was commissioned in 2014 by ThyssenKrupp Industries. We have RP plus ball mill combi circuit with the design capacity of 240 TPH for PPC, and the design power was 28 kWh per ton of cement. As of now, sir, we have beaten both of the parameters, and now we are on throughput of 300, and we are consuming the specific power less than 19 kWh per metric ton. Sir, if we see our throughput journey, then we are continuously improve our throughput, and for achieving this parameter, we have done lots of modification and many projects. Which we will discuss in the coming slides, sir. So we have taken many energy initiatives also. Some of major energy saving projects are here, sir. So we have replaced ball mill shell liner replacement, grinding media optimization, energy efficient oil-free compressor installation, and energy efficient AC installation. Sir, previously we have conventional liners, and the same was replaced by the specific thin liners, T-shaped thin liners, and through this we were get the benefit of 1.42 kW per metric ton specific power. And if we can see, sir, this helps us to optimize our media pattern. And in 2019-20, we were on 23% media loading, and as of now, we are on 16.5% media loading only, and this gives us the benefit in specific power. So this is our grinding power trend. We can see, sir, from 28 to 18.76 journey. So our major components for grinding powers are ball mill, roller press, separator fan, and auxiliary drives. So in ball mill, we reduced the power from 10.32 to 6, in RP 8.85 to 7.57, in separator fan 3.87 to 2.39, and auxiliary power is also reduced to 2.43. For ball mill, sir, we have done the modification of that shell liners, which we'll already discussed. And for roller press, sir, in this we replace the roller and regularly optimize our gaps for better grinding and reducing the power. In separator fan, sir, we have studied the gas volume of separator and reduce the false air and get this power. And in auxiliary power, we have also done many projects, replace the Dld drives by VFD drives in back filter fans and etc. So if we can see CI benchmark, then we are on the top in RP plus ball mill circuit. As well, if we compare from VRM, then also we are on only 18.76 specific power.
Almost equal. Yeah.
Yes, sir. Sir, other than this, we have installed energy efficient oil free compressors in our plant. So previously we were using the conventional LP compressor, which motor rating was 132 kilowatt and operating on 120 to 125 kilowatt rating. That was consumed 2.2 kWh per ton of fly ash for unloading of fly ash. Now we replace the same with new technology, oil free compressor. Its maximum pressure is going up to only 2.7 bar, and the motor capacity is 110 kilowatt. This is now consuming 0.9 kWh per ton of fly ash, and definitely this project gives us the benefits in the compressor power. So as well, we have done lots of in lighting power. So for lighting power, we have replaced our conventional ACs with BLDC ACs. So the main advantage of this AC is that it is consuming only 800 watt power for 1.5 ton AC, and conventional AC is consuming 730 kilowatt watt power against the BLDC AC. So if we talk about BLDC AC, then this is using permanent magnet, and conventional AC are using conventional electromagnets. So for less heat consumption and less maintenance, this were giving us the benefit in power. So if we talk about the energy saving projects, then from 2017 to 22, we have done 42 major projects, and with total saving of 98.78 lakh kWh, and total saving in rupees is 684 lakh. Sir, these projects consist of installation of 14 numbers of VFD in back filter fans across the plants, 100% LED lighting in plant, and we also have the occupancy sensor in offices and lobbies, and this all lighting were controlled from CCR, sir, so that timer will on and off automatically during the morning and evening times. And further, we are planning to install the weather sensors in the lightings to automate the same. Then, sir, roller replacement and gap optimization. Last year we replaced our roller, and we regularly optimize our roller gap to maintain the grinding of clinker and for better power optimization in roller press. Sir, then in 2019, we optimized the gas volume of separator fan and arrested the false air in separator fan. It gives us lots of benefits and help us to reduce the power of separator fan. Sir, as well grinding, we are working on other sections also. If we see, sir, packing plant power consumption, we were on 1.55 kWh per ton in 2017, and now we are on 0.73 kWh per ton. For this, sir, we have installed VFDs in packing plant, reduced pressure setting of packer from 6.5 to 4.5, and one of major project is, sir, RFID implementation. So RFID is automatic logistic and packing management system. This will help. This project will help us to reduce the specific power of packing plant. So compressor power. Compressor is also one of the major component in grinding unit for power. So we were on 1.11 in 2019, and now we are on 0.73 kWh per ton of cement. So for this, we optimize the loading and unloading pressure of compressor, install P&V system in compressor house, and we replace the compressed air cleaning system with body cleaning blower in site, and arresting the leakages and false air by regular audits. So if we see our PET cycle 6 trend, then our target was 0.0092 MTOE per ton, and against this we are achieving 0.007 MTOE per ton, which is very less than our given target. In this, sir, we already conducted MEA project, MEA audit, mandatory energy audit, and these were, sir, some ongoing projects of mandatory energy audit. Some of these are already completed, and we are working on the other projects also. Thank you, sir. That's all from our side.
Thank you,
Thank you.
Rajiv and Amrut team.
Yeah.
This is from the industry side. The normal industry side is a difficult phase running from the plant inside the conditions, locations, all these
Right.
things. I really thank you, Rajiv. You done a good job, great job, Amrut.
Yes.
It's going good ahead in the JK. Thanks
Right.
once again for your presentation.
Thank
It
you.
will be giving energy to all the participants to they also decrease the power consumption, especially the ACs, which is consuming unknowingly.
Right.
Done a good
Right.
job. Thank you. Thank you.
Thank you. Thank you.
Vaibhav, can we go for question and answers or something else?
Yes, sir. So,
I request the participants. Okay, Giridhar, you can continue.
yes, sir. So, we request the participant to post your questions in the Q&A tab in the Hive platform. Sir, we have a question for IKN. What is the temperature of air recirculated for hot air recirculation, and what will be the fan efficiency in case of existing cooler if you want to go for a hot air recirculation?
Hot air.
Thanks for the question. For hot air recirculation, we normally take the air to 100 to 120 degrees centigrade. That is the maximum to 100 compartment. And the efficiency of the fan depends on the fan supplier. If the existing fans may not be used because when the temperature goes 100 degrees centigrade, the fan cannot take it. Therefore, we need to go for a new fan.
Okay. Thank you, Madhu. Vaibhav?
Yes, sir. The second question is also to IKN only, sir. They want more details on IKN AFR feeding system and whether it can be modified with the existing preheater.
Yeah, if any calciner is there, we can retrofit, and we need tertiary air duct, hot air to be connected to that one, and it has to be sized based on plant to plant. There is no standard size, So probably the interested customer can contact us so that we'll be able to work on individual model.
Thank you.
Thank you, sir.
Okay.
The next question is to Pfeiffer. What is the major difference between VR and VC type separator?
Yes, VR is for raw material grinding, and VC is the cement grinding. And let's say the major difference from the design itself, it's related to the fineness. You see, cement grinding, when we are talking about 3,000 to 5,000 plane, the rotation speed is different, and also wear protection to be different because we are handling abrasive materials, whereas the VR type classifier is for the raw material. And when it's not a very abrasive material, let's say, then wear protection is of a different kind. The earlier one was called SLS-B and BC. BC then for the cement purpose.
Thank you, Henrich. Vaibhav?
Okay, sir. We don't have any further questions, sir. So you can give your concluding remarks.
Yeah, very good. Thank you all the participants and panelists, and also CIA giving me time and sharing this along with you big people like all the team members here, and also Vaibhav, Murli, and everyone. So first of all, the Rahul has set a very good context for the meeting today. In overall, I will thanks to him first of all.
Thank
to
you,
going
sir.
ahead with the Mr. Henrich also given up the MVR and all these things, how the pressure reduction and how we can increase the capacities with the lower CO2 saving of carbon footprint and all these things. And the Vikram is provided a very good presentation on the savings and improving the capacities and decreasing the carbon footprint and all these things again. Madhu, a well-known person in the cement industry, I came because if you ask any pyro engineer which cooler is required, if the people management gives the permission, everybody say I came. I don't know what will happen to other manufacturers. This is only for discussion point. So the ICAN cooler really I will also appreciate. We are using for several years. And also they are entered in the AFR market and pyro market. This is a good thing. Madhu, we will also contact you for the AFR immediately.
Thank you.
I have no idea that for the AFR mod business.
Okay.
Only today I come to know. Thank you, Madhu. Good job done there also.
Thank you.
Pankaj is also given a very good for the AFR material, how to use, what are the things required, refractories and all these things. Refractories. This is a really great thing. Several things we are also learned today. Thank you, Pankaj. And the great thing is for the industry side is participation. Mr. Anirudh, Dani and Raju was there.
Yeah.
So we thanks because the people are highly slogging in the industry level because I am there, so I can know the difficulties. Thank you, Anirudh. At least you participated because we are unable to participate also several times. Knowingly.
Right.
So from my end, thanks to one and all. And we will meet some other time with again CIA can conduct some other programs like this to give share the knowledge to the across India at least. Thank you, CIA team, CA chairman, everyone. Thank you, Anirudh. Thank you, everyone.
Thank you, sir.
Thank you.
Sir.
Thank you, Chairman. Thank you.
Thank you, sir. Thank you.
All the best from
Vaibhav, can we
Germany.
disconnect?
Yes.
Thank
Yeah.
you. Thank you. All the best.
Thank you, sir. Thank you, sir.
Thank you.